about fractions, and I guess the first thing we can talk about is what is a fraction, right? So a fraction is just one number, so a number divided by another number. So that's literally what a fraction is. So a is a number, so a and b are both just numbers that we both know, right? So like, let's say 5 over 6 is a fraction. So 5 over 6 is a fraction. 2 over 3 is a fraction. 0.2 is not a fraction. That's a decimal place, because this, you can convert it to a fraction if you make this 2 over 10 or 1 over 5, this becomes a fraction then. But at 0.2 it's a decimal, it's not a fraction. So a fraction has to be in this form right here, a over b, where a and b are both numbers. So I guess with fractions you can add, multiply, subtract, and divide, but let's look at different types of fractions. So we have proper fractions, which are like 5 over 6, 2 over 3, and you'll notice in all these three numbers that I've written right here, 5 over 6, 2 over 3, and 2 over 10, all those three fractions, a is less than b. So 2 over 3 is a proper fraction. That means this is like a percentage of something, proper fraction, because 2 over 3, so let's say I gave you a circle, right? Let's say you had a pizza, right? A circle. So let's cut it into 3 pieces. So that's 3 pieces right there. So 2 over 3 means you get this slice and you get this slice right here. And this slice is for someone else. So that's 2 over 3 is a proper fraction. But as soon as I say 4 over 3, well, this is an improper fraction. And this means that the numerator, so this is a numerator, and this is the denominator. So this is just some vocabulary that you need to know. Denominator. Okay, so that's a numerator, that's a denominator. So in this video, we'll do like some very basic stuff, and we'll also do some pretty advanced stuff with some algebra. So 4 over 3 counts as an improper fraction because, well, the numerator is bigger than the denominator. 4 is bigger than 3, so it's an improper fraction. Over here, 2 is less than 3, so the numerator is smaller than the denominator, so it's a proper fraction. So what would 4 over 3 look like? Well, that's the thing, right? We don't really know what 4 over 3 looks like in this case, because that's why it's an improper fraction, because we can't really draw it, because 4 over 3 is more than 1. And if you put 4 over 3 in your calculator, you will get 1.333333 repeating, right? And we're going to now see how to convert this into a mixed number. So an improper fraction can go to a mixed number. Now you might be thinking, what is a mixed number? Well, a mixed number, we'll see what it looks like, and then we'll be able to define it. So 4 over 3. So let's just do normal division, right? So we have 3, and we're going to do 4 divided by 3. Okay, so 3 goes into 4 once, so that's 1 right there. You subtract 3, this is traditional long division. So 4 minus 3, you get 1. And we stop over there, because now 3 doesn't go into 1 anymore, right? So we can't do anything else. So now what we do is, we take this right here, we put that 1 in front, and then we have this 1 over here, so we do that 1, and then divided by that 3 that we divided everything by. So you get 1 over 3. And this is the mixed number for 4 over 3. So a mixed number has an integer, it's called an integer, which is just a full number. So you can think of it as a full number if you don't want to think of it as an integer. And then it has a proper fraction. Proper fraction. So a mixed number can be converted into a proper fraction and an integer together. And now let's say I gave you a mixed number. So let's say I gave you 7, and then I gave you 5 over 6. Okay, let's say I gave you this, and then I told you, what is this as the improper fraction? Improper fraction. So how would you go from 7, 5 over 6 to the improper fraction? Well, what you do is you take the denominator, 6 right here, this is the denominator, remember? You multiply it by the integer, and then you add that to the numerator. So we do 6 times 7 plus 5. Of course, we follow BitMath, right? So 6 times 7 is 42, plus 5 is 47. So you get 47. So you have 47, and then it's going to be improper. So that means you're going to divide by, and now you leave the denominator as it is. So you divide that by 6. So that's how you do it. Now let's see if we can get back from this to this. So now let's go in reverse, okay? So we're going to do 47. So let's do it down here. We're going to do 47 divided by 6. And we're going to see if we get the same mixed number. So 6 goes into 47 7 times, right? 7 times 6 is 42. So 6 times 7. And then we do 47 minus 42. We get 5. And now 6 can't divide 5 anymore. So we leave it how it is. So we have 7. And then remember what we did. We did this number here. So in this case, our number is 5. So we do 5 divided by what we were dividing by in the first place. In our case, is 6. You get 7 5 over 6. And that is exactly where we started. We started with 7 5 over 6. So we went from a mixed number to an improper fraction, and over here we went from an improper fraction back to the mixed number. So now, what have we learned so far? Let's take a step back. So we know what a fraction looks like. We know that the top bit's called the numerator and the bottom bit's the denominator. We know that those are both just going to be regular numbers, so like 5 over 6, 2 over 3. We know a decimal place is not a fraction, but you can make a decimal place into a fraction, and in this case we get 2 over 10, which is also 1 over 5. You can simplify. And I'll tell you what simplifying fractions, we'll go over it very quickly. We know if the numerator is smaller than the denominator, then we have a proper fraction, and we can see what it looks like. But once the numerator is bigger than the denominator, we don't know what it looks like, and that becomes an improper fraction. And an improper fraction, you can convert it into a mixed number, which looks something like an integer and a fraction put together. And then from a mixed number, you can go back to the improper fraction by doing the denominator times the integer plus the numerator, and then you divide all of that by the denominator. I'm saying it a lot fast right now so that it's just like a summary, but just watch the video again if it doesn't make sense, and it will eventually start clicking once you do enough practice. Make your own mixed numbers and make your own improper fractions and try convert between them. So what is simplifying? So let's look at simplifying. Simplifying fractions. So simplifying basically means we have 2 over 10, right? Okay, we have this given to us. Well, we know 2 and 10 have a common divisor, right? So a common divisor is something that divides both the numbers equally, or that can divide both numbers without a remainder. So in this case, 2 is our common divisor. So 2 times 1 is equal to 2, right? So we put 1 over here. And then 2 times 5 is equal to 10. So we put a 5 over here. So 2 over 10 is actually the same as 1 over 5. And this is the simplest form, because once you have a 1 over there, that's already the simplest form of all time, because you can't, the only number that's going to divide 1 is 1 by itself. And if you do that, you'll end up getting the same thing again and again. So let's look at another example. Let's look at 13 over, let's do 42 for now. Let's do 42. Well, we know 13 is a prime number, so the only thing that's going to divide 13 is 13. So 13 times 1 is 13, so we do 13 over there. And then what goes into 40? Does 13 go into 42? Let's think about it. So 13 times 1 is 13, 13 times 2 is 26, 13 times 3 is 39, 13 times 4 is 52. So this actually is not possible, because you don't have a number. 13 does not divide 42 to give you a proper number without a remainder. So this actually cannot be simplified. So this cannot happen, and you would leave this as 13 over 42. And this is actually the most simple form of the fraction that you can ever get. So you can't simplify this further. But as soon as I say 13 over 52, well, we know 13 goes into 13 once, so we have 1 over there. We know 13 times 1 is 13, 13 times 2 is 26, 13 times 3 is 39, 13 times 4 is 52, so we put a 4 over there. So now this is our simplified form. So in this case we can simplify it, in this case we don't simplify it. Let's do one more example. Let's do, what should we do? Let's do 10 over 85. Okay, so what do we do? Well, we know 10 goes into 10 one time, so we can do 1 over there. Then how many times does 10 go into 85? Well, 10 times 8 is 80, and then 10 times 9 is 90, so we can't really do anything here. So that won't work. So this is not possible. But let's look at 10 over 85 again. Let's do it over here, 10 over 85. Well, we know 10 goes into 10 once, but 10 is not going to go into 85. However, 5 also works in this case. So 5 goes into 10 two times, so we can put a 2 over there. And then 5 goes into 85, so well, 5 times 17 is 85, so 2 over 17. And now this is actually the simplified form of the fraction. So it doesn't always have to be 1 over something. It has to be the smallest possible number in the numerator divided by the smallest possible number in the denominator that you can't simplify anymore. And simplifying is just getting a common divisor that divides both the numerator and the denominator by that number without giving you a remainder at the end. So now we know all about simplification, and we know what fractions look like. And now let's look at working with fractions. So we look at adding, subtracting, multiplying, and dividing fractions. So let's look at that over here. So we're going to start with adding fractions. So add. Okay. Let's say I give you, let's start simple. Let's do 2 over 5 plus 4 over 5. How would you do this? Well, we need to make sure that the denominator for both the fractions are the same. So we need to make sure these are the same. And in this case, they're the same. We'll look at a case when they're not the same. So in this case, they're the same. So if they're the same, you just add the numerators together. So now we just add, like how you normally would. So you get 2 plus 4 is 6. And then we leave the denominator however it is. So this 5 in our case, we leave it as 5. And you can leave it as 6 over 5, or if you want, you can convert it into 1 over 5. Remember, this is just the mixed version of the improper fraction. That was pretty simple. Now, what if instead I gave you 2 over 5 plus 3 over 8? Now what do we do? Now you see, the thing is, these two are not the same. So not the same. So what do we do now? Can we just add? No, we can't just add because they're not the same denominator, right? So there's a method called cross multiplying. So what we do is, see the numerator of the first one, you multiply it by the denominator of the second one. So you do 2 times 8 and you get 16. Okay? This is also called butterfly cross multiplication, or a butterfly method. It's just because it's going to end up looking like a butterfly. So you do the numerator of the first one multiplied by the denominator of the second fraction, plus, because there's a plus right here, you do the numerator of the first fraction times the denominator of this, the numerator of the second fraction, sorry, multiplied by the denominator of the first fraction. So you do 3 times 5, so you get 15. And then for the denominator, we do the denominator of the first fraction times the denominator of the second fraction. So just 5 times 8, which is 40. And now we can just add everything up as it is. So 16 plus 15 is 21. And then the 40 stays as 40. So you get 21 over 40. So that's how you add two fractions that don't have the same denominator. So let's look at another example, right? Let's look at 3 over 8 plus, let's do 5 over 9. So how would you do this? Well, again, you do 3 times 9 first, you end up getting 27, plus we do 5 times 8 and we end up getting 40. Then you divide that by 9 times 8, which is 72. So we do 27 plus 40 in the numerator, that's 67, and then divided by 72. Can we simplify this? You can't simplify it any further. You can try, but you won't be able to simplify this. So this is the final form of the fraction. And over here as well, this is the final form of the fraction. You can't simplify this anymore. You can try it if you want. Now look at subtracting. It's the exact same, but instead of adding the two numerators, you're going to subtract. So if you have 2 over 5 minus 1 over 5, well, we just do 2 minus 1, right? Then you get 1 over 5, because the denominators are the same. But as soon as I say 2 over 5 minus 3 over 8, well, now you're panicking. You're like, okay, what do I do? It's the exact same thing. You do 2 times 8, so you get 16. And instead of adding, you just subtract. So you do minus, now you do 3 times 5, which is 15. And then you divide that by, again, you multiply these two together and you get 40. So you do 16 minus 15 is just 1 divided by 40. That's all you have to do. Let's look at another example just so that we know we're comfortable. Let's do a big number. Let's do 12 over, let's do 19 minus 3 over 4. What does this look like? Well, we do 12 times 4, get 48, minus, now we do 3 times 19, which is going to give you 57. 48 minus 57, divided by, and then we do 19 times 4, which is 76. Okay, 48 minus 57 divided by 96. And you end up getting 48 minus 57 is negative 9. So you get negative 9 divided by 76. And that's fine. You can have a negative fraction. No one's saying you can't have a negative fraction. Well, I guess I should have mentioned it at the top over here that you can have a negative fraction. But it doesn't really make a lot of sense. But in case you got a negative fraction, that doesn't mean you're incorrect. That just means that this number right here, 3 over 4, is bigger than 12 over 19. And if you put it in your calculator as a decimal place, if that works for you, you will see that 3 over 4 is actually bigger than 12 over 19. Try imagining a pizza with 19 slices, and then you only get 12. And then make a pizza with just 4 slices, and you get 3. You will see that 3 over 4 is bigger than 12 over 19. And that's where you end up getting a negative answer. Okay, so far so good. Addition, subtraction, very easy, very simple. If they're the same numerator, if they're the same denominator, then we just do whatever it is with the numerators that we need to do. And if they have different denominators, then we do the cross multiplication method. Now, what if you're multiplying fractions? Let's say we're doing 3 over 5 times 1 over 8. What does that mean? And this is actually even easier than adding fractions, because what you do is you multiply these two and you multiply these two. Doesn't matter what they are, doesn't matter if they're negative, if they're not the same, if they're the same. You just multiply. So you do 3 times 1 is 3, and then you do 5 times 8 is 4, so you get 3 over 40. That's literally it. There's nothing else you need to do. Now I'm going to show you something interesting. This can make your work easier. Let's say I give you 5 over 16 times 24 over, let's say I give you 2. Let's say I give you an improper fraction, right? Okay, what can we do here? So now I want you to look at this. So you see 16 and you see 24. Well, you can simplify this, and you can also simplify 24 and 2. Let's do 24 and 2 first. Well, we know 2 goes into 2 once, so that becomes a 1 right there. And then 2 goes into 24, 12 times. So that becomes a 12 right there. So now I've simplified 24 over 2 to become 12 over 1. And that makes sense, right? We know 24 over 2 is 12. So 12 over 1. And now you can still simplify. You can do 12 and 16. So you can simplify these two as well. So as long as you have a numerator and you have a denominator, and if you're multiplying, you can simplify even though they're not on the same fraction. This is a different fraction, this is a different fraction. But if you're multiplying and you have the numerator and denominator separate, but you can see a common factor, then you can simplify it further to make your calculations easier. So we're looking at 12 and 16. So we know 12 is not going to work because 12 doesn't go into 16. But we know 4 is going to work, right? So 4 goes into 12 3 times, so that's 3. And then 4 goes into 16 4 times, so that's 4 right there. Okay, so now we actually have 5 over 4 times 3 over 1. And now this is way easier to multiply. You just do 5 times 3 is 15 divided by 4. Because 4 times 1 is 4. And you can change this into 3 over 4 if you want. It's up to you. But yeah, that's basically all you have to do. Let's look at another example, right? Let's say I gave you 6 over 9 times 5 over 3. Let's say I told you to do this, right? Let's just do it the long way first. Let's do 6 times 5 is 30 divided by 9 times 3 is 27. So we get 30 over 27, which is equal to 1 3 over 27, which is actually equal to 1, and then you get 1 over 9. Okay, so we have that. Now let's look at if you simplified it, right? So if you did 3 and 2 right there, so because 3 goes into 3 once, so we have 1 right there, and 3 goes into 6 2 times, so we have 2 right there. Well, now we have 2 times 5 is 10, so we have 10, and then we have divided by 9. And what's this? This is also equal to 1 over 9. So you actually end up getting the exact same answer. So you get 1 over 9 here, and you get 1 over 9 here. So you can simplify the fraction first and then multiply, or you can multiply and then simplify. You'll obviously end up getting the same thing. Now one last thing. Now we're going to do division. So now this is the final thing. And still division is easier than addition and subtraction, but it's a bit more difficult than multiplication. And I want you to think about this. So how can I make you think about it? Well, let me just tell you what it is first, and then maybe we can do like a thought experiment. So let's say I said 5 over 6 divided by 2. Okay, I'm doing 5 over 6 and I want a half of that. So what does that give me? Well, that is equal to, I'll tell you right now, is equal to 5 over 12. Now how did I get 5 over 12? So what you do with division is you do 5 over 6, and then from the division sign you make a multiplication sign. So you're allowed to do this. But since you're changing the whole operation, it's like math is saying, okay, you can do this if you want, but then instead of dividing by 2, I want you to multiply by 1 over 2. So whatever this fraction is right here, I want you to flip it over. So this is actually 2 over 1 if you think about it. 2 over 1 and 2 is the exact same thing. So this is 2 over 1. If you're going to multiply it, if you don't want to divide, you want to multiply it, then okay, just change 2 to go to the denominator and make 1 go to the numerator. So now you have 5 times 1 is 5. Divided by 6 times 2 is 12, so you have 5 over 12. So these two match. Let's do another example, right? Let's do 3 over 7. We're going to divide, so let's do 3 over 7 divided by 9 over 13, for example, okay? So what do we get? Well, as we said, we don't know how to divide, so let's multiply. So we do 3 over 7 multiply by, but now we change these two around, so we get 13 over 9. And if you want the official name, this is called taking the reciprocal. Reciprocal just means 1 over whatever is in the fraction. So 1 over this would actually just end up changing the whole fraction to become the denominator comes to the numerator and the numerator goes to the denominator. So you get 3 over 7 times 13 over 9. You can simplify, so that's 1 and that's 3. And then you have 1 times 13 is 13 divided by 7 times 3 is 21. And that's going to be a final answer. So now when you think about it, right, because when you're doing 1 divided by 2, you're going to get a half, right? That makes sense. But think about it, what you're really doing is 1 times 1 over 2, and you're also getting a half right there. So when you're dividing something, what you are actually doing is you're doing multiplied by 1 over whatever you're dividing by. So it's not like math is just saying that, okay, you can just do it because I want you to do it. It's because this is actually what we are doing when we're dividing. It's like division is not really a thing. Multiplication is a real thing, but division isn't really a real thing. You can think of it like that, right? Division really is multiplying by the reciprocal of something. That's what division really is. And you could argue that the only two operations that really exist are addition and multiplication. So these are the two important things. Because even when you're subtracting, what are you really doing? If I'm telling you 5, this is just me going off on a tangent, but if I'm telling you 5 minus 3, well, what you're really doing is 5 plus, and then you have minus 3 right there. It's this exact same thing. So addition and multiplication are really the two things that exists in operations. And even then, multiplication, you could argue, is actually just addition, is repeated addition. So you could say addition really is the only operation we have, but we won't go into that too much. I just wanted you to learn about some fractions. I want you to see what a fraction looks like, recognize the numerator, recognize the denominator, recognize a proper fraction and visualize it, recognize an improper fraction and see you can turn it into a mixed number. Recognize that when you have a mixed number, you can turn it into an improper fraction, and then an improper fraction, you can turn it into an integer, and a proper fraction, you can turn it into a combination of them. You see how to go from an improper fraction to a mixed number, and from how to go from a mixed number to an improper fraction. We learned about what simplifying is, right? If you have 2 over 10, well, you can simplify that to 1 over 5. We already went over how to do it, so I'm not going to go over it again. We learned that some of them can't be simplified, and then we just leave them how it is. So like this right here. And then we learned that you can divide the numerator and the denominator sometimes. So we did that over here. I'm going to skip a little bit. So we decided that we can simplify when you're multiplying fractions. You can just simplify the numerator and the denominator to like make the calculation easier. But let me not get ahead of myself. Let's go back to addition. We learned that if the denominators are the same for addition for the two fractions, then you just add the fractions together to get 2 over 5 plus 4 over 5. Since the denominators are the same, you just do 2 plus 4 on the top, you get 6, and then you leave the denominator as it is, which is 5, so you get 6 over 5. If they're not the same, we do a cross multiply, or the butterfly method, and we do the numerator of the first fraction times the denominator of the second plus the numerator of the second times the denominator of the first. That's the numerator of the final one, and then you divide that by these two denominators multiplied together. Just do some practice with that and it will make more sense. Subtraction, exact same thing, but instead of adding the numerators, we subtract the numerators. And then we learned what multiplication was. We just multiply the numbers as it is. And we learned actually that division is multiplying by the reciprocal of something. And reciprocal just means doing 1 over whatever we have that we're dividing by. And yeah, this is a tangent right here. We don't really need to worry about it. But yeah, hopefully that made sense. It's kind of a long video on fractions, but we went through the basics. And yeah, if you want to see harder fractions, if you want to see algebra with fractions, then yeah, let me know in the comments. And if you enjoyed the video, please like, share, comment, subscribe, and let me know what else you want to see in future videos. So yeah, thank you for watching.